Hello, so let's talk about the cutoff trees for golf event. So you are given a metric, and let's talk about the cell. So 0 represents the cell you can now walk through. 1 represents the empty cell that you can walk through. Alright, this is pretty irrelevant, but a number that is greater than 1 is a tree. So this is a tree. So if there's a value greater than 1, it's a tree that can be walked through. And you want to cut off the tree by order, so from smallest to tallest. And if you cut off, you want to set the cells to 1, and you always start from 0, 0. So this is pretty much it. And then if you cannot cut off, you return -1. Alright, so this is actually pretty challenging, but let's just break down the logic and then you'll be able to solve it. So I always start at this cell. Maybe I can use better notation. So you're starting over here. So this is an easy metric. So what happens if I have something like this, right? And then you're always starting from here, but you want to find out where is the smallest tree first. So you'll walk from here to here. So you cut off this one. So this is actually 2 steps. And then you remember where you left off, and then you want to find your next tree, which is this one, right? So back to here. So this is another 2 steps, and then you cut off, and you reset the value to 1 just in case you forgot. And then yeah, so the last tree you cut off is here, right? You want to find out the next one is going to be what? 3, right? So you go over here, cut off, so +2, and yeah, right here. So last tree, and then the next tree is 4, so you come over here, cut off, so +1. So you want to remember the step because you need to return the total step, the minimum step you need to walk through, right? So this will be the last tree you cut off, and then from here to here, cut off this one. So 1, 2, 3 +3, and then from here to here, +2, and then +1 at the end, cut off this one, and then everything should be okay. So just want to make sure that you know what entire the question is asking. Okay, so what you need to do is you want to find out all of the trees. Find out all of the trees, and just make sure that you add all of the trees according to the coordinate, and then make sure that it's in the order. So it has to be PQ, and then you want to set a constraint based on the height. So set constraint something like this, I cannot spell, and based on the height. So once you have this one, then you can actually traverse every single iteration, and then you want to say, oh, my last position was here. You want to go over to the next point position. So this is pretty important, and then once you find it, you will just keep adding the step. If not, if this one is actually return -1, you want to say, oh, I'm not able to find it, so I return -1. So yeah, so pretty much it. So let's see. So I have priority queue. I spelled wrong. Priority queue, and then passing in array. I'm gonna go PQ, and new priority queue, and then I need to set a constraint A, B. Based on my height would be the index 2, and then PQ equal to get tree order, something like this, and then you just pass in the forwards. So probably PQ in the array get tree order, and here's the forwards. So if the what's the problem? So sorry, for loop, right? You need to traverse forest size f++, and then you will traverse a column forest.get 0.size and then j++, and then you need to make sure you have partiq set pq equal to new. So you will set this one to here, and if the forest.get i.get j is greater, let's look at this. A number greater than 1 represent a tree. So you want to find 1 greater than 1. I mean, the 1 itself is empty, right? You don't need a tree to cut off. So you will just add the position ij and also the height into the PQ. You return PQ, right? So this is pretty much set up the PQ, right? So why not doing this? Alright, so once I have PQ, I want to get my minimum step for all of the tree. So get minimum step based on my forest and PQ. So if this function return -1, then I'm completely, not able to cut off the tree. So one more second. Okay, so what you actually need to do for this one is actually to keep on track the total step, and also traverse the PQ until it's empty. And just make sure you know where's your last position. So last position and set equal to 0, 0. It's because you're starting from 0, 0. And yeah, pretty much it, right? So I will say, oh, my current node is going to be PQ.poll. I want to say, oh, step equal to what? Get steps. I will have to traverse the forest. I will have to traverse the PQ. So my last position was this one. I need to traverse to the new position. So it's going to call node. So if the steps is equal to -1, which means you are not able to, find the path to cut off the tree, then you will return -1. If you cancel total step will plus equal to step, and you make sure you reset the value, the forest .get node at 0 .set node at 1, comma 1. So you set this index to 1. So this is, you get a row, you get a column index, and then you set the value to 1, and also you remember the last position should be your node, right? Then you will return the total step if you have it, right? Okay, so let's take this function and get step. So what is the forest PQ? Alright, so last position. So last position should be my source position. So source node in destination node. So this is a new position. That's going to be my destination. Alright, so I don't want to traverse any so on my iteration from here to here. I mean, this tree is too simple, so what happened? This one. So imagine you have, let me create a bigger picture. So imagine you have 2, 1, 4, 5, 0, 3, 6, 7, and this should be 0. So if you imagine that you want to traverse from here, this is simple. It only takes one step. But what happens if you want to traverse from here back to here? You don't want to just using the same, the cells over and over again, right? So you want to make sure where you have go through, and then you want to set equal to visit, right? So new boolean forest.size for the row and forest.get 0.size for the column. And definitely you need the steps equal to 0. And what else? You need a queue to know where you are going for the next position. So you will start from source node, right? So it's gonna be source node 0, comma source node 1, and then yeah. So make sure you set the visit right away. Source node, and change this one equal to true. So while the queue is not empty, right? While the queue is not empty, then I can traverse my size equal to queue.size, and then size greater than 0, size minus, so it would, you know, traverse every single possible path, right? But also 4 different directions. Look at where's my 4 different directions? Southwest should be right here. Directions, yes. So I need to create a direction array. So -1, 0, 1, 0, and 0, -1, 0, 1. There's 4 different directions. So I need to pull my value from the queue, right? So it's going to be null equal to queue.pull. So if I pull this one out, and then if this one is actually equal to the destination node, I'm going to return the step, right? Because I found it. Alright, if not, I need to traverse the direction. So in next x equal to direction 0, no 0, next y equal to direction 1 plus no 1. And you want to make sure it is in a boundary, so if not, you want to return, not return, you want to ignore. Forest.size. Next, less than 0. Forest.get 0.size. This is you want to continue, you don't want to keep traversing. And also if the forest.get next x .get next y is equal to 0, which is not able to walk through, you want to ignore as well. And also the cell you have been visited, you want to ignore as well. So this would be next x, this would be next y. So once you have it, once you satisfy these 2 constraints, then this is actually meant that you can start put yourself into the queue and make sure you have the visits ready. So you visit because you put into the queue. And then once this is that one iteration for the 4 different direction, right? So you will increment your step right here. So this will be it. So if not, then you will return -1. So it should be okay. So let's see what AI not doing well. So where's my, oh, this is the array. I actually forgot that. And this is what? Q.offer. Did I spell this wrong? Oh, This is the in array. Okay. Okay. What else? Is it direction? Direction? Oh, directions. Okay. 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 A little bit typo, but yeah. Alright, so let's talk about time and space. So if you are working, you need to code this kind of structure. So you make sure like this is super straightforward. So the main function is always the least code you have. So you get a PQ, and I just realized you probably don't need PQ in this function. I have no idea why do I put a PQ right here, but let's see if I run it. Did I break it? No. Alright, so yeah, so what's the time and space for this? Let's look at this. PQ, get tree order. So this is a time, all of n times n, and this is also the time as well, right? You sort it. It's gonna be n log n, but whatever. This is the worst case, all of m times n. This is a space. You can consider all of the value in the PQ, so all of m times n. Alright, so the worst case is this guy. Get minimum stat. So this is the space constant. Okay. So this is a traversal, right? And this is the traversal as well for different directions. So let's talk about the time. How many elements in your PQ? It's going to be the worst case. It's going to be every single element, right? All of m times n traverse this m times n time. You get this one. So how do you get from the current cell to another cell? I mean, if you have this, so imagine like you have 1, 7 right here. I mean, imagine you traverse every single one of them. Okay, 1, 9, and then later on you have 2, and then is it 8? And then what else would be a good one? And actually this is not a good one. 1, comma here, 2, comma here, 3, comma here, 4, comma here, and 5, comma there, 6, comma here, 7, comma here, 8, comma here. So this is like the furthest distance you ever go, right? Alright, so the worst case won't be m times n. Okay, so the worst case won't be m times n to go the direction. So yeah, so this is all of m times n, and this one is all of m times n, so it's going to be m squared, and this is the time. So space is all of m times n. So if you have a question, leave a comment. So this question is a little bit long, but if you actually understand what I'm doing is, I mean, you should be okay. If not, then rewatch and leave a comment. And I will talk to you later. Bye.